Hey, what's going on, guys? Is here. In this video, I'm going to be writing 6502 code using the tiny basic interpreter to save that code, and then later on fitting the code to the supermon 64's assembler. So it might sound weird, but actually something similar has been done before in micro ADE, which stands for assembler disassembler editor by Peter Jennings, that was written for KIM-1 back in the day. But since that program didn't work for me on my ESP32 based KIM-1 emulator that I'm currently talking to by serial port, I decided to make my own program. And the last video I've been demonstrating the process. I've been shooting the monitor with the camera, like typing this live. But the picture was awful, so I considered using the serial communication that can connect in my ESP32 to the USB port of my laptop, so I can record the screen instead of recording the monitor, the actual physical monitor, using my smartphone. So now hopefully the picture is much better. But anyways, it's not about the technical things, it's about how it feels as a developer. So the core difference is that having the editor that allows to enter the code line by line and then get kind of bulk assembled to the final binary executable. So anyways, I'm gonna be writing the simple hello world in this video, and it will be two pieces of code. So the first code is just to take the user input from the keyboard so that I could type hello world by hands and store those bytes, because I don't have an ASCII lookup table here. So that's the first thing. And then once we have that in zero page, I'll then write a program to actually print that string. That's pretty much all about it. So without further ado, buckle up and we begin. So I'm going to Southends space G, and we're in the basic, tiny basic by Tom Pittman territory. So just to give an idea, this is basic actually. I can print strings here, expressions, whatever. So it's actually, this is basic, it's not just a random program. Just to give you an idea. But we're gonna be using this to write some assembly code. So I say 10 assemble 0400. So the origins of the 400 is gonna be considered here. Well, let's start with the CLD, although it's not necessarily needed. Just I like how the code layout goes like this. Now, now if I have a look at my cheat sheet, so we have the address 1E5A to get the character from TTY and store it to the A register. So 1E5A, that's what we need. So let's go 20. I want to jump subroutine 1E5A, then 30. So what next? I want to say STA, 0 page, and the X register. Yes, and then I want to say, then I want to increment the X. Then I want to compare whatever we have in the A register with the carriage return byte, and if this is the if it's carriage return, that we just break. Otherwise, I want to say branch not equals to the eventual to 400s, and this is going to be 401, right? So branch not equals 0401, because 0400 is clear direction, a clear decimal flag. Okay, let's list the program. Yeah, all good, but yeah, let's say, well, even though here the X register most likely would be equal to 0 by the time of executing this program. Anyways, the problem is that I missed the line that actually initializes the X register to 0. So let's, for instance, say 15, and I can say LDX and zeros there, and then list again. So we just inserted the line, which is really handy, almost like a real editing. And now we need to change the branch at the line 60, because now it's going to be to 400s, 1, 2, 400s, and 3 now. So 60 branch not equals to 0403, and list again. And now that should be working. So yeah, we're going to be storing this to the 0 page. Okay, I just escaped from basic, going to 0 page, so there is nothing there, no bytes. But if I now go to A032, where's my driver program to assemble to fit the lines from the basic code editor to the supermon's assembler. So here we go, G, and all these dots means that every dot stands for a line in a in a basic editor to be assembled properly. So we have 1, 2, 3, 4, 5, 6, 7 lines, right? Yeah, 7 lines being assembled. If we go to 400s, we have the bytes there. Well, I probably didn't demonstrate this, wasn't the case before, because it was empty, I swear. And still, since we didn't run the program, we don't have anything yet here. So just to give an idea in regards to the disassembly, so we disassemble the 400s, sorry, 9548, disassemble 400s. So we have the exactly the program that we had. So let's just make sure the 0403, and yeah, we have exactly the program that we just had in our basic code editor, but now it's been assembled to 6.0 machine code, so we can run this program from now on. So if I just say go to 400s and run, now it asks me actually to input. Yeah, it's okay. I just can overwrite. It should be fine. So hello space world, and once I press enter, it just drops out of the program because it just took the user input, what it is intended to be doing. That's it. Now if we go to 0000, we already have these bytes here. Just make sure that these bytes are into the hello world. 9548, go into a super monitor and memory location at 0, and indeed we have this hello world, the very first bytes, as you can see. Okay, so now let's go to 300s, and this memory 300. So this is where we have our basic code. So, well, we could have probably just erased that. Yeah, I'll probably go for this. If I say fill from 300s to, let's say 350 and zeros, okay. And now I go for memory 300s. Yeah, it's now empty. If I now go for, just to get away from here, go into 2000s back, and well, actually 2003, so it's the warm start of the basic. Okay, so let's now, it shouldn't be anything there, but if I start writing some code, it should be starting, like, start saving from scratch. So let's start with the same thing. 20 now. Remember that I need to say LDX, LDX 00. Then I want to say LDA now. So from the 0 page, indexed by the X. Then whatever is there, I want to print this. Jump to subroutine 1 EA0. That's the KIM. The KIM-ROM address to output the character to the TTY. Okay, then I want to increment the X. Then fairly similar things, so comparing with the value of carriage return, hexadecimal D or decimal 13. And branch not equals, so it's not that we want to branch to line 30, and that is going to be so 400s for CLD, LDX 401, 0402, 403, 02, 0403. Should be fairly nice. So let's list the program. Okay, and now let's try to compile and run it. So I go to A032 and G, and it compiles. So far so good. So now 400, so already should be having a different program. Just to make sure that is the case, disassemble 400s. Oh, what have I done? Disassemble 400s. Okay, so we have, yes, branch not equals and then break. Yeah, that's okay. So now let's try to run this. I just say G to go to 400s and execute whatever is there, and we got our hello world. Well, okay guys, so this is it from my side. I hope you've enjoyed this video. The links to the software I've been using and partially created would be available in links in the description below this video. So feel free to use this and run around with this. This is it from my side. Thanks for watching. Until the next time, and take care.